All right, so we are going to continue talking about rational expressions. Again, word rational meaning fractions. So we're going to be talking about simplifying fractions. But these fractions are going to look a little weirder. And they're going to be complex fractions. So they're going to be fractions within a fraction, right? And so here's what I mean. A complex fraction is a rational expression that has at least one fraction in the numerator or denominator or both. So it looks something like these guys. So we've got a small fraction up here and then two small fractions down here, still in the numerator and denominator of a bigger fraction. But you can see this, and some of them can get as complicated as you could ever want, like that guy right there, right? Now, to simplify these, it becomes a matter of clearing those smaller fractions, right? And when you clear a fraction, right, it's almost like you're solving an equation with fractions in it. And so something like this, try to make something up really quick, right, where the least common denominator here is 15. What we did in Algebra 1 was that we multiplied everything through by 15. And then you can diagonally simplify. Like this, those 15s would divide out, leaving you with just 8. You can divide the 15 and the 5 out and get 3 here for the 15. So 3 times 1 is 3, and you'd get 3x. This was 5. 5 times 2 is 10, and then you'd go solve that equation. So it's the same thing. We're going to clear these small fractions either in the numerator and denominator by finding the least common denominator first, right? We talked about this with our adding and subtracting. And then multiply everything by the least common denominator, right? And so we're going to see, do you remember how to find the least common denominator of a rational expression? And we're going to factor all the tiny denominators and then take each factor from each denominator one time, right? And so we'll see if we can't make that make a bit more sense. So find the least common denominator of any of these polynomials, right? Well, we have to factor everything so we can see all the factors and be able to piece together our least common denominator. So the x squared minus 1 will factor into x plus 1, x minus 1. And so our least common denominator, that's all we're doing here, is just find the least common denominator, would be x plus 1 because they both have an x plus 1. So we're going to take x plus 1 one time from each denominator. And then the x minus 1. Right, would be your least common denominator. Another way we have said this is to take the factors that they have in common and the ones they don't have in common, and that will create your least common denominator. So, next one, factor out of 2 in that first polynomial. And then the second one we factor into x minus 3, x plus 2. And so our least common denominator is to take whatever they have in common, which is definitely an x plus 2, and then what they don't have in common, which is that 2 from the first one, and then the x minus 3 from the second one. Right? All right. Here, we go 2x plus 1, of course, and then we factor this. We can do the cubes, the cube thing, the SOAP stuff. So our first denominator is the cube roots, and then our trinomial is the first cube root squared, and then multiply them together, and then the second cube root squared, and then we SOAP the signs. And so our least common denominator would be what they have in common, which is the 2x plus 1, and then what they don't have in common, which is 4x squared minus 2x plus 1. Okay? And then over here where there's 3 of them, so x plus 4x minus 2, factor this next one into x minus 2 and x minus 2, and then the last one, x plus 4, x minus 1. And so what they have in common and what they don't have in common is one way to say it. When there's three like this, sometimes it's better just to say, all right, I'm going to take each factor from each polynomial one time, right? So in other words, I've got an x plus 4 here, and when I take that x plus 4, that takes into account the x plus 4 that's over here, right? I'm going to take that x plus 4 from the third polynomial. The x minus 2 will help account, so I got to take an x minus 2 from everybody. So there's an x minus 2 there, and that's it, right? And then, but there's another x minus 2 that I have to use, and then an x minus 1, right? We can only take each factor from each polynomial one time. So when I took this first x minus 2, I accounted for those x minus 2s, but there's a second x minus 2 in the second polynomial that I still had to bring as the least common denominator also, right? So there you go. All right. Once we've found the least common denominator, we're going to multiply every tiny fraction by that least common denominator. All right? So the least common denominator for these four tiny fractions, here are our denominators, 2, 3, 4, and 6. Hopefully you recognize that that's going to be 12. Right? So now I'm going to multiply by 12. And then diagonally simplify. So this is 6, 4, 3, and 2. And understand that all of these other guys, the 2, the 3, the 4, and the 6, divide out to 1. So we get a denominator of a 1 in all of these tiny fractions, which means that we don't need to worry about writing down the denominator, because anything divided by 1 is itself, right? Blah, 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 blah. So anyway, we get 6 times 1 over 1, which is just 6, and then 4 times 1 over 1, which is just 4, 3 times 1 over 1, which is 3, and 2 times 1 over 1, which is 2. So the tiny fractions are now gone. That was the whole point. That was what we wanted to do. Now we get something that makes a little bit more sense to us, and we can simplify from here. So believe it or not, this whole fraction is just 2. Okay. All right. Let's try this one. We need the least common denominator. Remember, this one has a denominator of 1. So monomials are always tough. You want to find the least common denominator for all the numbers, all the coefficients, which is going to be 9. And then any variable in a monomial, we want to take the highest exponent variable, which is just an x to the first here, so it's just 9x. So we're going to multiply every tiny fraction by 9x, do a little diagonal simplification, and go from there. The 9x and the 1 won't divide out, so we just get 9x over 1, which is 9x for the first guy. These x's will divide out, leaving a 1 there. 2 times 9 is 18. And then this denominator here we divide out and we get 4x. We would want to try to factor down. We can factor out a 9 in this numerator, which is great but doesn't really help us much. So we're left with this right here. All right, same deal. Find the least common denominator, multiply by that least common denominator, and get those tiny fractions cleared out. Right here, I've got monomials again in my denominators. Coefficients and numbers, it's just going to be a 1. That's the least common denominator, so I don't need to worry about bringing that over. I've got an x to the first, and I've got a y to the first as being the highest exponent variables. So that's our least common denominator. So multiply every tiny fraction by xy. divide out your common factors there, so we get y plus, divide out there, x squared, x times x is x squared, divide out the y's here, and we get x, and then here we can't divide out anything, so we get xy times 1, which is xy. Now we can factor out an x in this denominator, but remember you cannot divide these out, right? X in the denominator is a monomial, but the x squared in the numerator is part of a binomial. Monomials and binomials cannot divide each other out. So we just leave it simplified like this. Okay? All right. Moving on. We need the least common denominator for this guy. And now we've introduced monomials and binomials together. And so that monomial of an x is going to be part of it. And then since these guys have an x plus 2, we're going to bring that. And that accounts for all the different factors of our denominators. So now multiply everybody by x and x plus 2, x and x plus 2, x and x plus 2. So now we're going to divide out these x plus 2's, leaving us, because binomials will divide out binomials, right? Then we get 2 times x, which is 2x. Denominators divide out the x plus 2, x times 1 is x. Here these x's divide out, and we get 2 times x plus 2. You get 2x over x plus, and distribute here. And we simplify out to this. Remember, the x's in the numerator and the denominator cannot divide out because one of them's in a monomial, the other's in a binomial. Okay? All right. Here, we need to factor. We haven't talked about this in the last examples, but you need to make sure that you factor all of your denominators, including this guy. X squared minus 9 would factor into x plus 3 and x minus 3. And so our least common denominator becomes, well, x plus 3 for sure. That means that I can account for at least for one x plus 3 from every other denominator. And then an x minus 3, which will account for one x minus 3 in each denominator. And that takes care of all of our factors. And so now let's try this, right? I know that I'm going to multiply every tiny fraction by that least common denominator. And then I'm going to divide out the common factors. So what ends up happening, right? Like in this first tiny fraction right here, we've got an x plus 3 that are going to divide out and an x minus 3 that are going to divide out. And so we're not going to multiply that numerator of a 4 by anything. And that's because the denominator had every part of the least common denominator in it, right? So I don't need to worry about multiplying the 4 by anything. But the next fraction only has an x plus 3 in it. So those x plus 3's, the one here in the tiny denominator and the one in the least common denominator, are going to divide out. That leaves me with just an x minus 3 to multiply the 2 by. So really what we're doing is we're multiplying by whatever the denominator is missing. Right? Now in the big denominator here, this bottom left guy has an x plus 3 in the denominator. That means it's missing the x minus 3, so we can do 1 times x minus 3 and just get x minus 3. And add to it, the bottom right guy has an x minus 3 in it, which means it's missing an x plus 3, so we can multiply by x plus 3. And so now we're going to distribute. Simplify the denominator. And let's see, rewrite in standard form, we get 2x minus 2 over 2x, factor out a 2 from the numerator, and now I can divide out these 2's because the 2 in the numerator, since I factored it out, is a monomial, and the 2 in the denominator is part of a monomial, so I can divide those out, and we go x minus 1 over x. I can't divide those x's out because the x in the denominator is a monomial, and the x in the numerator is part of a binomial. You cannot divide numerator or monomials and binomials. Okay? So there you go. Okay. We need the least common denominator here, and the only way we're going to get that for this next guy is to factor some more. This will factor into x plus 1 and x minus 1. So let me take a look, and hopefully you recognize that the least common denominator is x plus 1, x minus 1. Now we're going to multiply each tiny numerator by whatever its denominator is missing. Right? The first tiny fraction is not missing anything, so it stays a 4. The next one is missing the x minus 1, so we multiply the 5x by x minus 1. The bottom left guy is missing both, so we multiply x plus 1 times x minus 1. And then we've got a minus 1 times, it's missing the x plus 1. Now we want to simplify, distribute, multiply together, whatever we can. These guys will multiply out to x squared minus 1. Distribute the negative 1 here. We get 5x squared minus 5x plus 4 over x squared minus x minus 2. And now we try to factor if we can. We're not going to be able to factor the numerator, so it doesn't really matter if we can factor the denominator or not. I mean, we could, into x minus 2, x plus 1. I'm going to take a look at the numerator one more time. And I just don't think we're going to be able to factor it. So, we're done there. Okay? All right. You try this one. Come up with the least common denominator, multiply through by that least common denominator, and then go simplify. Stop the video, start it back up, and you can check your work. Did you get this? The least common denominator is x minus 1, x minus 2, and x plus 1. The top left tiny fraction was missing the x minus 2 and the x plus 1. The top right tiny fraction was missing the x minus 1 and the x plus 1. And the bottom tiny fraction was missing the x minus 1 and x minus 2. And so we multiply all that out, combine like terms, and factor back down, and you should get to that. Okay? All right. Try this next one. Make sure that tiny numerator you factor all the way down to see all of the factors. All right, there you go. The least common denominator is x, x minus 1, x plus 1. Multiply each tiny fraction, each tiny denominator by what its denominator, each tiny numerator by what its denominator was missing, and you should end up with this right here. And then we're just going to multiply out and simplify out, and it should get you down to that. So this, when I wrote this numerator or denominator in standard form, I got negative x minus 1. I went ahead and factored out a negative 1 just because I don't like having that leading coefficient be a negative. It didn't end up making any difference, so if you didn't, that's okay. All right, we got one more, so try your hand at one more. Make sure you factor all three denominators. Find your least common denominator, and go from there. First of all, holy crap, this whole big thing simplifies down to 1. That's what I got. So when you factor each tiny denominator, x minus 3, x plus 2 for the first one, x plus 2, x minus 2 for the second one, and in the denominator, x plus 2, x minus 2, and x minus 3, after you do your grouping the x squared minus 4, you can factor on down to x plus 2 and x minus 2. So your least common denominator should be x plus 2, x minus 2, x minus 3, multiplying each numerator by what its denominator is missing, and you end up with this right here. Not as complicated as it looked when you first started factoring, right? All right, that's it. If you have more questions and not quite sure what's going on here, come on in and see me, and we'll figure it out, right? Homeworks in Canvas, have that done by next time.